Welcome to This Explainer. Today, we are unlocking the secrets of how raw, chaotic numbers are completely transformed into one of the most powerful strategic assets in modern business. I mean, think about the sheer volume of information generated every single second. It's honestly overwhelming. But what if all that chaos held the exact answers a business needed to thrive? Well, today we're going to explore the fascinating world of data analytics and modeling and see exactly how it turns that overwhelming mountain of numbers into a clear, reliable roadmap for success.
Okay, let's dive right into this. Have you ever wondered how top companies seem to know exactly what you want, sometimes even before you do? You search for one thing, and suddenly, boom, the perfect product appears right in your feed. It almost feels like magic, right? Or, maybe mind reading. But the reality is far more grounded, and frankly, a lot more interesting. It's not a crystal ball. The answer lies in the highly structured, rigorous science of data analytics, and understanding how it works is absolutely key to making sense of the modern market.
So what exactly is this science? Simply put, data analytics is the evaluation of unprocessed data sets to draw conclusions, identify patterns, and extract useful information. Think of it like a massive, high-tech refinery. It takes unstructured, chaotic, raw data, which on its own doesn't really mean much of anything, and processes it for human usage. This refinery often relies on things like machine learning algorithms, complex simulations, and automated systems. Once it's all refined, firms use this data to gain a deeper understanding of their customers, analyze their promotional activities, customize their content, develop new strategies, and even create entirely new products.
Now, to get from that raw, confusing data to those brilliant business insights, there's a very distinct factory line journey. We follow a strict 5-step data analytics process. We start by setting grouping criteria, then we move into collecting the information, organizing it, cleaning it up, and finally adopting the exact right analytical approach. This sequential method is absolutely critical. You really can't skip a step without compromising the whole operation. It is exactly how raw, unrefined material is methodically turned into highly valuable business intelligence.
Looking a bit closer at the first two steps, we always start by setting the criteria for grouping the data. We have to know what we're looking for, right? Are we segmenting by specific ages, populations, and incomes, or maybe by sex? And these values might be numeric, or they could be categorical. Once those parameters are locked in, we move right into step 2 and actively collect the data. This gathering phase casts a really wide net, pulling from internet sources, internal computers, personnel records, and broader community sources.
Right, so now we reach the middle of our refinery process. Step 3 is organizing. After gathering all that scattered information, it has to be arranged logically. This usually means putting it into a spreadsheet or a specialized statistical program so it can actually be evaluated. But before handing it over to a data analyst, we hit step 4, which is literally vital: cleaning. The data is rigorously scrubbed to verify there are no duplicates or hidden errors. Because, let's be honest, handing a messy, error-filled spreadsheet to an analyst is just a recipe for disaster. This cleaning ensures the document is completely comprehensive and accurate before the real analysis even begins.
And this brilliantly illustrates the final step. Once your data is pristine, comprehensive, and perfectly organized, we reach step 5, adopting the right type of data analytics process. The numbers are ready, sure, but businesses still need to apply specific models to translate these discoveries into actual usable insights. This is where the process truly adds value for executives and managers. Choosing the right analytical approach is what allows them to confidently make educated and prudent business choices rather than, well, just guessing.
When it comes to choosing that approach, there are 4 distinct types of analytics to consider, and it's pretty fascinating to see how they build on each other. First up, we have descriptive analytics. This looks at historical data and simply asks, what happened? Next is diagnostic analytics, which digs deeper into that past data to figure out why did it happen. Then we shift our focus to the future with predictive analytics, asking what will happen next based on the patterns we found. Finally, we have prescriptive analytics, the ultimate strategic tool which tells executives exactly what to do in order to achieve their future targets.
So, you might be asking yourself, why go through this entire 5-step process? Why invest so much time in organizing and analyzing? Well, it all comes down to a core contrast: guesswork versus data-driven decisions. Relying on intuition feels a bit like walking blindfolded through a fast-paced market. It's incredibly anxious and, frankly, risky. But processed, refined data removes that blindfold completely.
Data analytics enables businesses to significantly boost their market efficiency and predictably increase their overall profits, building plans based entirely on verifiable findings instead of just hopeful assumptions.
Which brings us to the massive payoffs of this entire discipline. Benefit number 1, data analytics drastically improves the decision-making process. By using advanced analytics technologies, companies don't just look at old numbers. They're able to continuously collect and analyze brand new data. This gives them an incredibly deep understanding of rapidly changing circumstances. Instead of panicking when the market shifts, they can adapt quickly, basing their major decisions on hard evidence, and resulting in significantly enhanced outcomes across the board.
There's a powerful quote from our source material that sums this up perfectly. Using data analytics significantly reduces the amount of guesswork involved in preparing marketing plans, deciding what materials to produce, and more. Just think about how painful it is for a business to just throw ideas at the wall to see what sticks. It wastes massive amounts of budget and valuable time. With analytics, you no longer have to guess what your audience wants. The numbers are already telling you exactly what to produce.
Now, what's really interesting about this next slide is the operational side. The second massive benefit is an immediate increase in the efficiency of operations. Data analytics acts as an indispensable tool to help firms streamline their day-to-day processes. By continuously monitoring the data, companies can pinpoint exactly where they are being wasteful. This allows them to effectively conserve vital resources, trim down unnecessary expenditures, and substantially increase their overall profitability.
I mean, think about the sheer resources wasted on advertising campaigns that completely miss the mark. When firms have a true data-backed understanding of their audience's demands, they solve this problem instantly. They immediately stop wasting time and money. They spend significantly less time creating promotional activities that simply do not fulfill those specific audience needs. By optimizing the workload to focus only on what actually works, the direct impact on the bottom line is enormous. But beyond operations and marketing, the ultimate goal of analytics is deeply human. Our third major benefit is improved service to stakeholders. While it's super easy to think that data analytics is entirely about cold numbers, automated algorithms, and massive spreadsheets, its highest purpose is actually human connection. Data analytics provides organizations with an incredibly in-depth understanding of not just their paying customers, but also their employees, partners, and other key stakeholders who keep the whole business thriving.
Having this deep, granular understanding changes the entire dynamic of how a company operates. It enables the company to tailor experiences precisely to individual needs. It allows for a level of personalization that simply wasn't possible a few decades ago. Whether a company is working hard to keep a customer loyal or trying to ensure an employee feels engaged and valued, this personalization is exactly what builds unshakable, long-lasting relationships. The data essentially teaches the business how to be more accommodating.
As we wrap up this journey from raw, unstructured chaos to refined strategic power, I want to leave you with a final thought to really chew on. Is your business driving the data, or is the data driving you? Understanding the 5-step process, selecting the right analytical models, and fully grasping these massive benefits is the first critical step to ensuring you are the one in the driver's seat, making confident, evidence-based decisions.
Listen, if you're trying to figure out how to turn that absolute mountain of raw data into a razor-sharp, actionable corporate strategy, you are in the exact right place. I'm really thrilled to guide you through this today. We're going to look at the powerful mechanics behind taking the unrefined digital earth of information and turning it into pure strategic gold.
So, think about your own organization for a second. How exactly do you turn those overwhelming, massive data sets into an actual corporate advantage? It's a huge challenge, right? With the massive expansion of big data, leaders are constantly struggling with scalability and automation. Because let's face it, data without direction is just noise. But through smart data analytics, you can radically enhance corporate decision-making. It's not just about collecting data anymore, it's about what you can successfully mine from it.
Okay, let's dive into this. Our roadmap today covers 5 clear steps. 1. Decoding data mining. 2. Setting the business objective. 3. Preparing the data. 4. Model building and patterns. And 5. Evaluating and implementing results. Let's jump right in.
Section 1. Decoding data mining. The core concept of knowledge discovery.
Before we build any kind of model, we need to know exactly what we're aiming for here. Data mining, or as it's formally known, knowledge discovery in data, KDD for short, is the extraction of patterns and other really useful information from massive datasets. Over the past couple of decades, thanks to the explosion of data warehousing technologies, this field has advanced dramatically.
It's literally the bedrock for businesses that need to translate raw data into meaningful intelligence. And when you pair this concept with advanced visualization technologies like Apache Spark, for instance, extracting those valuable insights has never been quicker. We're talking about rapidly bringing crucial business intelligence to the surface, whether it's fraud detection, pinpointing user habits, finding bottlenecks, or catching security breaches early. It's a game changer. And AI advancements are just accelerating this adoption across every sector.
Now, when we actually run these data investigations, the techniques generally serve two primary purposes. On one side, you have describing the target dataset, which is simply organizing, characterizing, and understanding the existing data through its relationships. On the flip side, you have predicting results using machine learning algorithms. Both are incredibly powerful, but they serve completely different strategic purposes for an organization.
To actually execute those predictions or descriptions, data scientists rely on a four-step process. First, establishing objectives. Second, acquiring and preparing the data. Third, implementing the actual data mining techniques. And fourth, assessing the outcomes. We're going to zoom in on each of these steps right now, starting with the very first one, which often dictates the success of the entire project.
Section 2. Setting the business objective. Identifying the corporate challenge.
So the crucial point to understand here is that setting the objective might actually be the most difficult element in the entire data mining process. Surprisingly, a lot of organizations just spend inadequate effort on this exact step. Data scientists and business stakeholders absolutely must work together to identify the specific business challenge. This collaboration informs all the data queries and parameters for the project. Analysts might even need to do further study to really grasp the company environment. If you don't know what you're looking for, you'll never find it.
Section 3. Preparing the data, cleansing and filtering for accuracy.
All right, once the scale of the problem is locked in, it's a lot simpler for data scientists to determine which collection of data is actually going to answer those crucial questions. But raw data is incredibly messy. Think of it like radio static. We have to eliminate what we call data noise. This means scrubbing the data set of repetitions, dealing with missing numbers, and tossing out extreme outliers. If you leave that static in there, it corrupts the algorithms and gives you false insights. Clean data is everything here.
Beyond just cleaning, there's another fascinating step called dimensional reduction. Think of this like packing a suitcase for a quick weekend trip. You don't bring your entire wardrobe, right? Just what you need. You have to minimize the features of your data to guarantee optimal model accuracy and calculation speed. Why is this necessary? Well, an excessive amount of features will totally bog down any further calculations. Data scientists purposely keep only the most essential predictors so the model runs fast and accurately.
Section 4. Model building and patterns. Extracting the hidden insights.
Now for the really fun part. This is where we finally get to extract those hidden insights from our perfectly prepared data. Depending on the sort of research, data scientists study intriguing relationships, things like frequent patterns, clustering algorithms, and correlations. Now, high-frequency patterns have very large applicability across a business. But honestly, data variations can often be even more fascinating. Surprising variations expose hidden areas, like possible fraud, that standard observation would just completely miss.
And this brilliantly illustrates how deep learning algorithms handle categorization. If your input data is marked, meaning it's labeled and we know what the categories are, that's supervised learning. We use a classification model to categorize it, or regression to forecast a specific probability. But if the dataset is entirely unlabeled, that is unsupervised learning. In that case, the algorithm actually compares individual data points to uncover underlying commonalities, and then clusters them based entirely on those shared, hidden features.
Section 5. Evaluating and implementing results. Attaining intended corporate goals. This is exactly where we bridge the gap between data science and hitting your actual corporate goals. After aggregating all this data and running our models, the findings have to be analyzed and understood by human decision makers. Before you execute a single strategy, your findings must strictly meet 4 criteria. They must be valid, original, practical, and above all else, comprehensible. If the business stakeholders from step 1 can't understand the output, the whole exercise basically falls flat.
But when those 4 criteria are confidently satisfied, we finally hit implementation. This is where knowledge discovery directly translates into reaching your goals. Your organization can now execute brand new strategies based on a verified, data-backed understanding. You are no longer guessing.
You are making decisions based on solid evidence to attain those big organizational targets.
So I'm going to leave you with a final provocative thought. Look at the data your own company generates every single day. What if you stopped viewing those massive data sets as just a storage burden and started seeing them as a goldmine of strategic opportunity? What hidden patterns is your organization's data waiting to reveal?
Hey, we're diving straight into how massive, overwhelming data sets are transformed into actionable business intelligence. If you've ever wondered how financial institutions make sense of millions of daily transactions, or how they seemingly predict market trends out of thin air, well, you are absolutely in the right place. We're demystifying the incredible world of data mining in finance. So, what exactly is data mining? At its core, data mining, which is also known as knowledge discovery in data, acts as the vital bridge between massive amounts of raw information and human comprehension. We're talking about the extraction of hidden patterns and useful information from truly massive data sets. The goal here is twofold. You either want to describe your target data set, or you want to predict future results and behaviors using various machine learning methodologies. Here is our agenda for today. 1. The Data Mining Toolkit. 2. 4 core mining techniques. 3. Finance and management applications. 4. Specific financial use cases. And 5. The takeaway. Section 1. The Data Mining Toolkit. Moving from raw facts to intelligence. When we strip away all the complex jargon, there are 4 core techniques we're going to explore today that literally act as the heavy machinery for processing and classifying data. We're talking about association rules, neural networks, decision trees, and K-nearest neighbor. These 4 methodologies are absolutely fundamental for business intelligence teams trying to translate their raw data into meaningful insights. Section 2. 4 core mining techniques, breaking down the algorithms. First up, we have association rules. This is a rule-based technique specifically used for discovering associations between variables inside a given dataset. It's heavily employed for something called market basket analysis. Think of it kind of like this. If a customer buys tomato sauce and cheese, the association rules might uncover that they're highly likely to purchase hamburger meat as well. By understanding these client consumption patterns, organizations can create incredibly effective cross-selling tactics and recommendation engines. Now, neural networks are fascinating because they actually replicate the interconnected layers of the human brain to process training data. Data moves from an input layer through multiple hidden layers right to an output layer. Every single node has inputs, weights, a bias or threshold, and an output. When a node's output value exceeds its predetermined threshold, that node literally fires, passing the data forward to the subsequent network layer. This is essentially the foundation of deep learning algorithms. But how do they actually learn? Well, they use supervised learning and a mathematical optimization process called gradient descent. The network keeps adjusting itself based on its loss function, which is basically a measure of how wrong its current guesses are. When that cost function gets down to 0 or extremely close to it, we can have very high confidence in the model's ability to produce the correct answer. Next in our toolkit is the decision tree. This methodology uses classification or regression algorithms to predict likely outcomes based on a sequence of distinct decisions. It gets its name because it uses a visual, tree-like representation to depict these potential results. It's built on 3 specific types of nodes: decision nodes, which are typically squares, chance nodes, represented by circles, and end nodes, which are triangles. Finally, there's the K-nearest neighbor algorithm, or KNN for short. This technique operates on a really logical assumption. Comparable data points exist in close proximity to one another. So, it measures the physical distance between a new data point and existing points, often using what's called Euclidean distance. Based on that physical closeness to other accessible data, it classifies the new point into the most common category nearby. Simple, but highly effective. Section 3. Finance and management applications, where theory meets reality. To really understand the stakes of this technology, consider this number: $2 trillion. Up to $2 trillion, which is roughly 2 to 5% of the entire global GDP, is laundered globally in a single year. We are talking about the illegal conversion of black money to white money. And these very algorithms we just broke down are exactly what sophisticated financial institutions use to track and stop this massive threat. Section 4. Specific financial use cases, solving high-stakes problems with data.
The spread of data mining applications across an entire financial organization is absolutely massive. It covers everything from detecting the illegal conversion of funds in anti-money laundering efforts, to predicting loan defaults, to determining optimal products for target marketing, right down to the data warehouses that move and evaluate vast transaction volumes. Let's look a bit closer at a few of these. Take money laundering, for instance. Criminals try to obfuscate their trail through 3 precise stages. First is placement, where illicit cash is injected into the formal financial system. Then comes layering, where they create complex transactions to disguise the origin. Finally, integration, where the funds re-enter the economy as legitimate assets. Data mining methodologies have advanced to the point where they are uniquely suitable for banks to detect this suspicious behavior across all 3 of these stages. Then there's the incredibly critical area of credit, because loan distribution is the absolute core business function of every single bank. Predicting risk is paramount. Predictive data mining systems automatically compute characteristics to manage massive databases and predict exactly the probability that a loan will be repaid. It completely transforms customer credit policy analysis from a guessing game into a precise, automated science. On the retail side of things, data mining and marketing combine forces for target marketing. By analyzing data, banks and financial firms can target a certain market and align optimal products with specific customer types. This ensures they're constantly maximizing their margins and keeping their earnings high by delivering exactly what the consumer wants, right when they need it.
But listen, none of this works in a vacuum. It all requires the design and construction of huge data warehouses. A business has to be able to retrieve and move massive volumes of data correctly and reliably. These data warehouses process a staggering number of daily transactions, supplying the vital backbone that allows artificial intelligence methodologies to actually evaluate all this information at scale.
Section 5. The takeaway. The future of predictive finance.
We've seen how neural networks, decision trees, and association rules invisibly drive everything from the loans we get to the products we're sold and the security systems protecting our economies. As these algorithms become increasingly better at mapping our behavior and predicting our risk, it leaves us with a fascinating and maybe slightly provocative question. In the future of predictive finance, who truly holds the power in our financial lives? Us or the algorithms? Thank you so much for